In this video, we will learn about the selection sort algorithm and how to implement it in C++. A selection sort goes through each element in the list and finds the minimum value. It places the minimum value at the beginning. Then it goes through each of the unsorted elements and finds the new minimum, which it places after the sorted element. It continues this process of going through the collection, grabbing the local minimum, and adding that value to the sorted part of the array. Let's say we have a collection of the elements 20, 10, 50, 2, and 5 in that order. On the first pass, the selection sort would determine that 2 is the minimum element in the collection, and would move 2 to the beginning of the list by swapping the 20 with the 2. Then it would iterate over the remaining elements, since 2 is already sorted. The remaining elements are 10, 50, 20, and 5. Since 5 is the minimum choice out of these, it gets swapped with the 10, so our sorted part of the collection is now 2 and 5, and the unsorted part is 50, 20, and 10. The minimum element out of these is 10, so the 10 gets swapped with the 50. The 20 and 50 are in order, so we don't need to do a swap. Notice that the elements in the collection are in order. Now that we understand the concept behind the selection sort algorithm, let's learn how to implement it using C++ code. Up at the top of the code, we need to include the vector header file. Let's create a function that returns a vector of integers. We will name the function selection sort, and it will take in one parameter, a vector of integers named list. Inside of this function, we will have an int variable named minIndex that we initialize to a value of 0. Then we will create an int variable named length that we set to list.size. After that, we will have a for loop that starts at int I equals 0, runs while I is less than length minus 1, and increments I by 1 each time. Inside of here, we will nest a second for loop, which will start at int j equals I, run while j is less than length, and increment j by a value of 1 each time. Inside of this second for loop, we will check if list at index j is less than list at minIndex. If that is the case, we will set minIndex equal to j. Outside of the inner for loop, but inside of the outer for loop, we will check if minIndex does not equal I. If that is the case, we are going to swap the elements at index I and minIndex. To do this, we can create an int variable named temp that we set equal to list at minIndex. Then we will set list at index I equal to list at minIndex. Next, we will set list at minIndex equal to temp. At the bottom of the function, outside of the outer for loop, we will return the list, since all of the elements have been sorted. That wraps up the code for our selection sort function. Now we need to test it. Inside of C++'s main function, we will create a vector of integers named numbers, which will add the numbers 20, 10, 50, 2, and 5 to. After that, we will have a vector of ints named result. Let's set result equal to a call to the selection sort with numbers passed in. Then we will use a for loop to iterate over each element in the result collection and output it to the console. When we run the code, notice that the elements in the list were successfully sorted, thanks to the selection sort function that we wrote. In this video, we will learn about the bubble sort algorithm and how to implement it using C++ code. With a bubble sort, we iterate over the collection and check each pair of elements. If the element on the right is greater than the element on the left, we swap the two elements. We continue to do this over and over until eventually we iterate over the entire collection and don't have to swap any elements. At that point, we know the list is sorted. Let's look at a conceptual example on a vector holding the values 20, 10, 50, 2, and 5. First, the algorithm would compare the 20 and the 10. Since 10 is less than 20, those elements get swapped. Next, the 20 and 50 are compared, and don't get swapped since they are in the correct order. After that, the elements 50 and 2 are compared. Since 2 is less than 50, those two elements get swapped. Finally, 50 and 5 are compared and swapped since 5 is less than 50. After the first iteration, the collection is now 10, 20, 2, 5, and 50. This is closer to in order than it was before the first pass, but some of the elements are still out of order. The next pass compares 10 and 20, then 20 and 2, which get swapped, then 20 and 5, which get swapped, and then 20 and 50. On the next iteration, 2 swaps with 10, and 5 swaps with 10. We can see that the elements are in order now, however the algorithm doesn't know that yet. After completing an iteration where no elements are swapped, the program realizes that the collection is sorted, and returns the sorted collection. Now that we understand the concept behind the bubble sort algorithm, let's learn how to implement it using C++ code. Let's create a function that returns a vector of integers named bubble sort that takes in one parameter, a vector of integers named list. Inside of this function we will have a while loop, whose condition we specify as true. At the top of the while loop we will create a boolean variable named swapped that we initialize to a value of false. After that we will utilize a for loop, which will start at int I equals 0, run while I is less than list.size minus 1, and increments I by 1 each iteration. Inside of this loop we will compare 2 adjacent elements in the list, which we can do by using an if statement with a condition checking if list at index I plus 1 is less than list at index I. Inside of this if statement will go the code to swap the elements, since if the code got to this point, we know that the element to the right is less than the element to the left of it, and therefore the 2 elements need to be swapped. To do this we will create an int variable named temp that we set to list at index I. Next we will set list at index I equal to list at index I plus 1. After that we will set list at index I plus 1 equal to temp. Now that we have swapped the 2 values, don't forget to set the value of the swapped variable equal to true, since a swap has been performed on this pass of the algorithm. Outside of the for loop but still inside of the while loop, we will check if a whole iteration has been completed without a swap taking place, which we can do by using an if statement and checking not swapped. If the code gets inside of this if statement, we know that the collection is sorted, so we will return the list. To test our code, we will change the function call inside of the main function to be a call to our bubble sort function. When we run the code, notice that the elements in our collection have been sorted, thanks to the bubble sort code that we implemented. Great work!